Thanks for joining us for another episode of DPC Radio. This episode was recorded live in Amsterdam at the Dutch PHP Conference 2012. For more information about the Dutch PHP Conference, visit our website, phpconference.nl.
Good morning, welcome. How nice to see people. I'm scheduled against really interesting people, so I'm really surprised how many people there are here. This talk is about Oauth. If you saw me speak about Oauth last year, that's fine, because this is completely different, and I've learned a lot in the intervening period, so enjoy, whether you saw it or not. I have some interesting stuff to tell you. This is just the required preamble for anyone who doesn't know me. Hi, I'm Lorna. I'm Lorna Jane on Twitter. Feel free to heckle, and that's my website. So, if the answer is Oauth, what was the question? What problem does Oauth actually solve? So, Oauth is here to avoid this situation. My husband pointed out that I should not put my passwords in my slides. So please don't abuse this information. So we have this person, and she gives her credentials to her smartphone or other device. The choice was a BlackBerry image or an iPhone image. I refuse to have iPhones, so you're stuck with a BlackBerry, not an Apple fangirl over here. All right. So here we have a user whose data this is. She gives her credentials to the device. What happens? The device pretends to be the user. When we give our username and passwords to devices, they are impersonating us, dressing up like us with a matching hat and pretending to be us. So Oauth is designed to solve this problem. Oauth is open about the fact that there are 3 people in the relationship. Feel free to retweet that, then tell me how to say it in a way that just doesn't, I haven't found a good way that doesn't just sound really suggestive. So yeah, there are 3 people in this relationship. We have the user that we saw right at the start, and it's her data. And her data belongs to some kind of Oauth provider. The device is the third party. And Oauth allows us to say, this device or application can access my data. They are not me, but they can access my data. So it makes that relationship very clear. You may know there are 2 kinds of Oauth. There is Oauth1, which has been around for quite a long time. And there is Oauth2, which I think is still technically in beta. But they kept telling me it was almost ready. That's been going on for a year and a half. So everybody's implemented it already. So pretty much that spec, I think, is as stable as it needs to be. If you've used Oauth1, please try to imagine that Oauth2 is this awesome, shiny new thing that does not have the same name. Because genuinely, these 2 things got very little in common other than they solve the same problem. They're very different technologies. If you've had any bad experiences with Oauth1, don't worry about it. Oauth2 is entirely a different experience. Oauth1 is in use in many systems. I am going to talk a little bit about it and how it works. A little bit. Oauth2 is what I hope you're having to integrate against, what I very strongly recommend you implement yourselves, and will be the main focus of the talk. I'm actually going to begin with Oauth2. Oauth2 kind of takes the stuff that we did in Oauth1 and solves a lot of the performance problems. Because quite often, between the user, the provider of her data, and the application that consumes it, often there is some trust. And Oauth1 assumes there's none. So there's lots and lots of checks and balances. And actually, in Oauth2, quite often, we provide a mobile application that is made by the same person, the same company, the same organization as the main application. So then It's not some kind of rogue, downloaded it off the App Store and don't really know who made it kind of an app. Some apps are more trusted because we already have a relationship with the person who made it. Sometimes we might be consuming our own data. So then the user and the application are kind of the same thing. And Oauth2 allows for that. It's also much, much better suited to any kind of high-performance systems. Facebook have been huge drivers, really, of the Oauth2 Spec development and the way that that has evolved. If you are Facebook, you do not want to go back and do a real-time lookup on user credentials for every request that comes in, because it's every resource on every page, lots of different information. Just Oauth1 would just take their servers down in a moment. So Oauth2 separates out the authentication part and then actually serving all the different resources. That really helps with scalability. So I'm talking about all these different parts of servers. Let's have a little look at how this really goes together. So we have the user who already has a relationship with the application. So the application are those two symbols on the right-hand side. And we have the device who's over on this side, and they're going to make some relationships with these people. The guard dog is the authentication server. It allows you to have access or not. This is the data store. This is where the actual data we're interested in is stored. So once we've got access, once we've agreed that this device can get past the guard dog with the permission of the user, then the device can talk straight to the data store and pull in whatever information that we need. So before you do anything, as with all API things, you're going to register this application, device, consumer, and give it an API key. We just need to identify it. And commonly, we'll ask you what your application is, what it does, and also we'll ask for a callback URL. So this is a little security feature. When you register your application, we'll ask you where you'd like your users forwarded back to. When you send as a user, you have to supply the same information. We're not just going to forward people willy-nilly with your API key. So you can usually supply a list, but typically we agree this application accepts return users to here. An example of signing up for an API key is in Joined In. I'm the project lead of Joined In, and the joy of open source is it makes a brilliant case study. I was like, oh yeah, I really need a public Oauth2 implementation so that I can grab the code and talk about it. So it's in Joined In. The Oauth2 services have a few endpoints. First of all, obviously, on the website, we have the place for you to register for your API key. We also need a place on the website for users to come, sent by the application, to say, yes, I did mean that to happen. I am comfortable with this. You may have access. And then we have the resources as well, which will be served from the existing web service. The API has two endpoints, a separate authentication server and a resource server. So we kind of get permission, and then we get our resources from a different server. And again, that's kind of a feature for scaling. It allows you to separate that logic, and if you are in a situation where you need to run those separately, you can. And the client needs to have a callback URL that we can come back to. And it might be a device one, it might be a web one, it just depends completely how you're implementing the consumer side of this. So if Oauth is all about trust, how do we establish trust? Well, Oauth2 gives us a choice. In Oauth1, there was only one way to agree trust, and it involved something called a dance, which I'll talk more about in a minute. I do promise not to dance, however. We establish trust. We're trying to allow this device and this authentication server to agree we're all good and we can get through. So we've got a choice. We can get an authorization code and exchange that for an access token. We can do an implicit grant, where the user says, aha, that's fine, and we get an access code immediately back with that. We can use the resource owner credentials, and in that situation, you are putting your username and password into that client application, but it critically does not store it. And there's the trust. You have to trust that it's not going to. If you have downloaded something random from the App Store, you probably don't have that kind of relationship. And there's also the situation you can have the client credentials. I'm going to talk about each of these in turn. The Oauth2 Spec also includes for expanding on this. So if any of these don't fit whatever you're doing or things that we might be doing as common practice in 5 years' time, we don't need a new spec for that. We can just keep adding new ways of doing the authorization grant, and the way that we access resources will be just the same. So, the authorization code, this one is the most like Oauth1. So if you've used Oauth1, this looks probably the most familiar. You will use this typically for server-side applications. So if you're consuming an Oauth service from PHP, I have a little dashboard thing that pulls in joined-in data that uses it. And the way this works is the user downloads the client from the App Store or Google Play or whatever, and says, I'd like to give you access to my data. The user will be forwarded over to the website, and they'll see a page which says, I accept, or I don't think so. If they accept, they will come back with I'm trying to remember the word, a code, the authorization code. Once you've got that code on the server side, you do another round trip, say, here's my code, and you get the access token back. So you send the user to go there and here, and then you make another round trip to say, right, I have got the code that you sent the user back with, please give me an access token. Once you've got your access token, you can move on. So we send the user from the device over to the main application, and we send our client API key, so we identify our client. We send the callback URL, where we would like them forwarded back to. Remember that you normally have to supply this when you sign up. A lot of providers will allow you to give a choice. Google does, for example, so you can put in your test servers, staging servers, as well as where you will really want to forward people to. The type of request that you're making, the scope, and the state. So the scope is how much access you would like. The type is going to be code in this case, because we're asking for an authorization code. The state is a nice feature. When you forward the user over to this original application for them to say yes or no to give you access to the user's data, you can send this state parameter. Whatever is in the state parameter will arrive back with the user and their authorization code when they come back to you. So if you need to attach any information to identify them or pass any additional information that is associated with their experience, there's a provision for that. So that kind of helps us do a nice joined up experience using this state parameter. So the user goes off from the device with these variables in the URL, and they see something like this. I picked the Twitter screenshot because I am guessing most of you have authorized access to your Twitter account at some point. And you press the big yes please button, hopefully. This is really important. If you do press yes, and it turns out that you downloaded something somebody's nephew made, and it's just tweeting to your Twitter stream or otherwise abusing your data, you will always be able to come back directly to Twitter and say, that third party no longer has access to my data. So it's not about changing your password. You can independently revoke any of the accesses that you have granted in the past. And that's very much an OAuth feature, and it's really important. Because we're open about the fact that the device is not you. They're not pretending to be you. We've agreed that there is a relationship. Okay, so you click the Authorize App button, and the user arrives back with the authentication code that you asked for and any state that you sent. So you can kind of persist things because this state variable will go round the loop. Once you've got the code, we do an extra round trip. So we go from our client or PHP, whatever, we go back to the authentication server and say, right, my user authenticated, here's the code you gave back to me. I confirm that I am this client. And they give you the access token. Yay! Access token is the aim of the game. So that's the authorization code process. If you are doing this server-side, this is probably the best way to do it. And one of the most widely supported processes of the flows that are in the Oauth2 Spec. Everyone still with me? Any questions? Just interrupt me or I'll just talk continuously. Anyone still alive? Okay, I got some nods. Thank you. Right. This is an alternative flow. So this is another way of agreeing that the consumer can have some access. It's called the Implicit Grant. And we use it for client-side apps. The reason that we use it for client-side apps is because there is no point in sending back some kind of code and then doing the round trip if it's JavaScript. Because it's in your browser, you can see it. There's no security there. You totally can use the authorization grant flow on a client-side app, on a phone, somewhere where people will have access to those access codes, but there's no extra value. So the implicit misses out that final round trip step, and we just do it in one go. So we just go from device, send the user, same kind of, exactly the same data, except our type this time will be token. They see the page, they say yes please. They come back, but instead of coming back with a code that we can exchange for an access token, they've got an actual access token, and we can just go ahead and use it. This is super simple, I quite like it. Where the security is not really critical, this is totally acceptable, and this is what I implemented for Joined In. So if you want to have a play with an example, feel free, be my guest. We even have a test site if you don't want to break stuff. Again, that persistent state parameter is used. So when you're sending users away from your site, you can get them back with any information that you need to attach to that journey. So again, a really nice feature. Okay. Resource owner credentials. This is the moment where you might be asked to put your username and password into an application. Now, if it's, I don't know, your application or the Twitter application or the Facebook application, you already have an account on Twitter or Facebook, I'm assuming you have some kind of trust with that organization. So if you're downloading the official app for something, or your company made this app or something like that, we've got a better level of trust. If you're downloading something where the documentation doesn't seem to have originally been written in English, and the reviews are not very good, probably don't put your username and password into it. What this allows us to do is to authenticate a user without having to send them to the website and then get them back. So in situations where you can't call back into your application, or it's just tricky, or you can't be bothered, or whatever, this is quite a nice workaround, especially, as I say, if it's a same provider application, go for it. So what happens is the user does input her username and password into the client. The client passes it on and gets an access token in response. Critically, at this point, the device does not store the username and password, nor does it have any reason to use it again in the future. With OAuth, we're not re-authenticating all the time, apart from apparently the Twitter joined-in login is doing that. I have a bug open that I haven't looked at. If anyone wants to fix that, that'd be awesome. But in theory, you establish the relationship, and until the user goes back and revokes it, it's still there. So you don't need to store the user's username and password because you shouldn't be needing them again. So you just get an access token back, and we're good to go. The fourth and final flow is the client credentials. This is where you want to give access to someone or something who is basically God. And what we do, it's something like a separate reporting user needs to be able to see all the data. It's not somebody's data, they have a certain amount of access just because of who or what they are. So, for example, your reporting user is just going to show up and be like, "Hi!" and get an access token in response. That's all they have to do. Show up and identify themselves with their client identifier. And they will be given an access token. And each of the access tokens is really just an identifier. Everything you know about access control, checking who someone is, can they see this, can they see that, stands. So you would do all of the sort of ACL stuff that you normally would once you've been able to identify who or what is asking. So I quite like this because there are situations where, you have very privileged consumers where you do want something to have access to everything for whatever reason. Usually it's an integration thing. It's between two applications internally. You're feeding the company dashboards that are shown on every bank of desks, or you're feeding some other use of data. And then you just want to be able to say, "Yeah, hi, let me in." And that's what this flow is intended for. It's not so much about granting a third-party access to a user's data that's held by this provider. But it allows us to implement this and handle it with access tokens as part of our existing Oauth setup. So it saves having another Auth mechanism and doing more work, which for me is a win. Okay, so that's 4 grant types. How do you choose? Well, who or what is consuming it? What will their rights look like? What are the relationships between the 3 people in the relationship? How well do they know each other? This is going really badly. Have they met each other? Yeah. It's not unusual at all for the providers to support more than one of these flows. So they may support server-side apps and client-side apps and still have the client credentials log in as well for different clients, different consumers. That's not unusual at all. Any questions about the flows? Okay. Some people did actually... Oh, yes, go on.
I assume that with the Implicit Grant flow, your client-side application authenticates itself to the authenticator.
Mm-hmm.
What's to stop an attacker from simply stealing those credentials that the client application authenticates itself with and reusing that instead?
You always use SSL. There's a slide. Bear with me. And then if it's not clear after I get there, ask me again. Okay? Okay, so we've chosen our flows, we've built our functionality. We've arranged how much trust there is between whom. And we have an access token. That's awesome. You read a lot of Oauth documentation, examples. It typically stops here. It's like, hey, you could do this, you could do this, you could do this. Now you've got an access token. Well, hey. So what next? Actually really straightforward. All we do is with all subsequent requests, when we're requesting resources from the resource server, we put the Oauth token, access token, in the header like this. So we send an authorization token, got my teeth in, an authorization header, which has OAuth and then the access token we were given. And you just put that in all your normal API calls, and it will be able to authenticate you. So for example, the joined in one. Okay. The joined in one, if you are logged in, it says at the bottom, it gives you a link to your user account at the bottom, and it's got some additional information in the API about whether you are attending or not, because it knows who you are. If it doesn't know who you are, that's fine. You still get some information. It's all open. You can get it from the website. So it's not everything is locked down, but if you do send the authorization header and I can authenticate you because your access token was valid, I can give you some additional information, exactly like being logged into a website or not. So it's not necessarily just about access or no access. The OAuth stuff allows you to identify a user and then give a response that's sensitive to who that person is. So this is why I was just peering at my screen, because my text is apparently tiny. Everything you already know about handling APIs, consuming APIs, that's it. You carry on doing everything you already know. The OAuth stuff is relatively simple. You send the one authorization header, and that's the only difference. I want to mention refresh tokens. Not every implementation has these. There is provision in the spec that you can use a refresh token. And if you were going to, what happens is, when you get your access token from the authentication server, you get an access token and a refresh token. The refresh token typically will be valid for a long time. The access token is valid for a shorter period of time. Just like sessions, they time out. So if you're working with this system, your access token will expire, and you use your refresh token as an authorization grant. So you send your refresh token, your client identifier, and you can get another access token, usually a new refresh token as well, back in order to keep on using the system. So if you've got a situation where there's more security considerations, this is probably a good practice. Some people use it, some people don't. I think Facebook do have it, Google don't. It just depends on the kind of access that you are asking for, the kind of systems that you're dealing with. I deal with joined in. It's not your medical data or your credit card data, or, so there it's very much a community thing, and we just have access tokens. You will see the refresh tokens, so that is the story with that. With the access control, I have a question. Go for it.
The refresh token, what is the added value of it? Is it that if you send a normal request, you send authorization token, not a refresh token, so if somebody intercepts your message somehow and gets your access token?
Right. So the question is, what's the added value of having the refresh token as well? So no one can intercept your message because you are always going to do this over SSL. Always, always, always. And there's a rant coming up about that. You can all stand by. The refresh token is what you use when your access token is expired. So it's expired, you make a request with the access. All your requests have the access token in the authorization header. One of them will come back with an error message which says your token has expired. And you will do the additional round trip with the refresh token to get a new access token and then carry on whatever you were doing. Okay? Yes, but it allows you to expire the access tokens.
Yeah, but let's say someone steals only the access token, then it will expire quickly. But if he steals only the refresh token, then you just have like an access token that is valid for a longer time.
How are you stealing tokens? We're going to do everything over SSL.
No, but the reason why you want more security is to, if somebody died of them.
I'm not sure what the question is. Okay. All right, let's talk about access control while we're kind of on the security topic. Access control. So you saw in the exchanges that I showed you earlier, the scope parameter, this tends to be quite limited, but it does allow you to indicate to the provider what level of access you'd like. So again, with the Twitter example, purely because I think it's mainstream, sometimes when you see the Twitter access page, it says this application would like access to your Twitter account. It can post to your timeline, it can do X, Y, and Z. So Twitter have 2, 3 levels of OAuth. They have read-only, read-write, and they've just introduced read-write and DM. So direct messages are not always available. Like, they used to be just everything or just read-only. So the scope is how you can indicate that. And typically the providers either only give one level or they don't give very many levels. But this is how it will be supported. This is what it's for. So that allows the client to request how much access they need. For example, the joined in, signed in with Twitter button, when you go through to the Twitter page saying, yes, I grant access, very clearly says, this application will read from your account. We don't request access to post to your Twitter stream because we're not ever going to. We want read access so we can just pull your username in so we know who you are. We're not requesting too much access. A lot of providers, like I say, don't really support the scope parameter, but as part of Oauth2, that is there. Typically, the user gets no choice. The client says, I would like this much access, and the user goes to a page which lets them say yes or no. And I'm sure I am not the only person who has gone to a Twitter page for something totally innocuous that just wants to identify me with Twitter to see it say, yes, you're granting permission for it to tweet and do this, that, and the other. And it's like, I didn't care that much. No. I think we'll see more support for the scope parameter and for clients to be able to request different levels of access. You don't often see users have any control at all. All right, HTTPS. Oh, question, go for it.
Are you allowed to implement that users can check off, for example, to post it to a Twitter timeline and then grant access to the rest?
I have never seen that. It tends, because Twitter has these 2 levels, read-only or read-write, the client requests which one they want, and Twitter shows you the appropriate message. The user, like I say, can only grant or deny.
But according to the spec, are you allowed to request access with one scope and actually grant access with another scope back?
I guess so, because it's up to the provider what it grants, but I haven't seen an implementation of that, so I'm not sure how the mechanics would work.
How would the client know? I mean, if I ask the application for access to X and Y, and I only get X, I only get a token back, nothing else.
Yeah, I mean, it would have to be outside of, but you could send back an access token, which just some of the stuff isn't going to work because you don't have permission to do it. And I think applications, both provider and client, need to be implementing their own access control arrangements anyway. So, yeah, I'd be interested to know. I haven't seen an implementation which does that. I wish they did because, like...
For example, in the Twitter case, you might want to just allow Twitter to authenticate you, but not actually let the
Yeah, and somebody needs to solve that problem because I see it time and again.
Well, actually, Facebook has something like that. Because you can say, like, they can only write, and you can choose who can see the messages, and you can pick only me.
Okay, that's quite cool. But I wonder if that's part of the scope parameter. I haven't played with it, so I can't answer. Yeah, okay.
Seeing as a much finer-grained access in some cases also where you can say, oh, I want them to see my business card, but not my personal information. But I think they must be using their own API for many of them.
Well, and also what you might see is the choice on the client. You know, you're going to link to your Twitter account. Do you want this much linkage, this much linkage, this much linkage? And then we can go through with the correct scope parameter. But that relies on the client being sensitive to it. It's not really I think it should be part of your relationship with the provider. But I haven't seen it like that. Boy, were you going to say something?
Just quick, what's the syntax of the scope parameter? Is it custom per provider, or is there some sort of...
Yeah, it's very custom. I think there are some conventions. I see a lot of read-only, read-write, but The Oauth2 spec is the woolliest thing you've ever seen. It's very vague. And part of that is because Oauth1 was so prescriptive and every application is different. So that's making it really interesting for people trying to write Oauth2 libraries, for example, because it tends to be based against the Yahoo libraries or the Google libraries, and you often have to kind of fiddle with them if you're using, because there aren't any specs about what the variables should be called or the different levels. You can end up adapting those quite a lot. Okay, HTTPS. So we've got this situation where we're sending usernames, passwords, access codes, access tokens, refresh tokens, and all kinds of things just over the URL. Oauth1 had this great big hairy built-in encryption system that used timestamps and nonces and all kinds of stuff. And Oauth2 has nothing at all. When you do this in development, if you're on a closed network or you're playing with toy systems, you're going to do this in plain. You know, my first round of development works over HTTP because it's just on my local machine. When you deploy to production, you will use HTTPS for Oauth2. It is not often that I am absolutely black and white about the right way to do something. But if you are not using SSL, you are doing it wrong. That's all I have to say about Oauth2. You must use SSL, and this is really, really important because we're sending everything in the clear. There's absolutely no checks and balances, pretty much. We are just sending, hey, here's my access token, you know, here's all the user information. They click yes, you get the code back. Brilliant. It's just going over the wire. So you must send all of this over SSL, that handy encryption protocol that we have already invented and learned to love. Yeah. And we literally encrypt the pipe. We don't send stuff in the clear. So we negotiate the encrypted channel between the 2 points. All of your OAuth traffic will go over this SSL. And ideally, you're already using it for logins and so on and so forth. But everything is going to happen over SSL. And that's all I need to say, really, about Oauth2 must go over SSL. So all of those security questions which I got, and you're right, it smells very, well, hang on a minute, someone's going to get this token and they can do anything, you've granted access, etc. That's why we must use SSL, because it protects us against the man in the middle, because we know that it can't be sniffed off the wire. Okay. I'm going to talk about Oauth1 unless anyone wants to make any more comments or ask me any questions about Oauth2. Wow. All right. Well, look, Oauth1 might seem a little bit last year, but there are quite a lot of implementations still alive and well. I have had to implement against, I think, 2 this year already. And also, Oauth1 was kind of painful. So if you have already implemented Oauth1, I know how keen you feel about going through that again to implement Oauth2. Okay? Oauth2 is awesome. If you have any opportunity to rebuild and replace it, please do. If you are in the situation where you need to consume something which is Oauth1, my sympathies, but that is why these slides are here, because it's actually a very different process. So I just wanted to run through that as well, because I know there are systems out there. If you are building something new, please don't build with Oauth1. Okay, Oauth1 invented its own encryption, and it was fabulous when it worked. I've always been pretty lucky, and I've never really had any major problems with it, but it has been hairy in places. It had its own encryption, so we needed a library to do it. Trust me, you do not want to be doing this in your own code. So we had a PECL extension, which was fairly good eventually. I got bitten by an upgrade between versions where they changed the flags and everything. I upgraded my server and stuff just spontaneously stopped working overnight. It was brilliant. And it had so many steps needed to establish the level of trust to allow the client to access the resources that it's known as the Oauth Dance, a sequence of steps. Oauth1 solved the same problem as Oauth2, how to let the Twitter client on the phone be, this is my client, not this is me. That stops any Blackberries going around wearing pink hats. And it had a single OAuth endpoint. So in OAuth 2, we have the separate granting access and then serving the resources. OAuth 1 didn't have that. Everything came into the one place. You were passing it all on every request. And it had its own encryption. It was pretty heavy to do. So, the Oauth Dance. The API key registration is exactly like you would expect. That is step 0. Step 1, client goes to the provider and says, I'd like a request token. Gets a request token. Gives the request token to the user, sends the user over to the provider. They do the accept deny thing. They come back with a verification code. And then the server does yet a third round trip back to the provider to say, here's my verification code, and gets an access code in response. So it's got additional round trips because you had to request a request token. The encryption requirements were, so we had a consumer ID and secret, which was used for everything, and it used a nonce on every request, and it used a timestamp, and something else that I've forgotten. And it sort of mashed these things up together with the HMAC SHA-1 stuff and sent all but one of the values over as well. So the clocks had to be in sync for the timestamp. And the consumer secret doesn't get sent in the packet. You've already agreed that beforehand. And then you had to unpack this whole thing. You sort of had to do it again with the values that you were given and try and make the same number on this side to be able to guess what the data was. Oh, my goodness. And it was every bit as fun as it sounds. So it was a good idea because it had it built-in encryption, and you could send it over HTTP, but it was process-intensive even with the PECL extension. Very difficult to debug when it goes wrong. Oauth 2 doesn't need an extension because we just lock it down with SSL. We know how that works. Brilliant. All right, so today, how do things look in the landscape of Oauth? Well, if you haven't built your Oauth implementation yet, please use Oauth 2. Oauth 1, yeah, complicated PECL extension. The PECL extension is fine, by the way. And people keep saying, oh, well, PHP doesn't support Oauth 2 yet. I tried to persuade Rasmus that we should build an Oauth 2 support into the PECL extension. But he just looked at me like I'd grown an extra head. So I guess we're not going to do that. He's right, we don't need it. But I think it would be nice to kind of be able to say, tick, yeah, we offer this support. Apparently not. He didn't quite say patches welcome. In fact, he didn't even say patches welcome, so it's probably not a very good idea. Oauth 2 requires SSL, and I've put and decision making. You need to make some decisions about where there is trust and where there isn't, how the flows will work, whether you will expire the access tokens and use refresh tokens. There's a few more things to make. It's a little bit less prescriptive. It's flexible, but that means you have to make decisions. So whether that's a good thing or not is sort of up to you. Okay, I'm almost out of time. I have a few resources for you. The Oauth2 Spec, riveting bedtime reading. Actually, it has really cool ASCII art diagrams in of all the stuff. So that's worth it just for that really good ASCII art. There's a great introductory article here, which is how I eventually stopped messing about with Oauth 1 and got my head around Oauth 2. If you are Googling and you see any hits on that domain, go there. The guy's a really good writer. He's on the Oauth 2 committee, and he really understands his stuff. He has helped me enormously. All the images came from the Noun project, which is an open creative thing. I'm going to get that wrong if I try and say it. So yeah, that's me. Thanks very much. There's my joined in URL. I build joined in, I maintain it. So if you could possibly take a moment to leave me some feedback, that would be awesome. Thank you.
DPC Radio is a production of iBuildings. The materials presented are copyright of the speakers. This episode is released under a Creative Commons Attribution, Non-Commercial, No Derivatives 2.0 license. iBuildings is a full-service web development company specializing in PHP development. For more information on how we can help you with your next web project, visit our site at ibuildings.com. Thanks for listening, and we hope you'll join us again for DPC Radio. you.